Okay, so once again, we want to use the separation of variables method to solve the equation. And you notice that this time around, we've got two y primes in our equation. So we want to bring those together to be on the same side of the equation so we can actually factor it out and have one single y prime to contend with in the problem. So if we subtract from both sides the 2y prime, we end up with y cubed y prime minus 2y prime is equal to just x. Again, we can factor out the y prime, so we've got y cubed minus 2y times y prime is equal to just plain x. And now we can replace y prime with dy dx. So we've got y cubed minus 2y times dy dx is equal to x. And these variables are very easy to separate. We just multiply both sides by dx. So we've got y cubed minus 2y times a dy is equal to just plain x dx. Now to solve this, we can integrate both sides. And in doing so, we're going to have a 1/4 y to the fourth minus a y squared is equal to 1/2 x squared plus c. And then if we want, we can multiply the whole equation by 4 to clear out these fractions. So that's going to take us to y to the fourth minus 4y squared is equal to 2x squared plus a new arbitrary constant c. All right, and then from here, this is an implicitly defined solution, and for most problems, you're fine just leaving it exactly as this. Every once in a while, there may be some kind of mathematical trick you can use to solve it. You will notice that this is actually quadratic in y squared, so you could actually complete the square to solve it. All you'd have to do is just add a 4 to both sides. Just take -4, take it in half, and square it. So if you do that, you would have your y to the fourth minus 4y squared plus 4 is equal to 2x squared plus c. Because again, when you add 4 to both sides, c plus 4 is still an arbitrary constant. You can now factor this as y squared minus 2 quantity squared is 2x squared plus c. And then you could take square roots of both sides of this and get y squared minus 2 is equal to plus or minus the square root of 2x squared plus c. You can then add 2 to both sides so that y squared equals 2 plus or minus the square root of 2x squared plus c. And then, of course, you can square root this again, and you would have your y of x function equal to plus or minus the square root of 2 plus or minus square root 2x squared plus c. And that's actually an explicit formula for a solution here. But again, if you're asked a problem like this in the homework, they're probably going to want you just to stop with the implicitly defined solution over there, rather than the explicit. And again, you normally can't find the explicit solution. This is just a kind of a quirky problem here that allows us this option. All you'd have to do in this problem is just change one of these original exponents, like make that a 5 or make that a 3, and you can no longer apply the quadratic completing the square technique.